Vítam všetkých, dúfam, že je ma počuť. A vítajte na tomto talku, ktorý má byť po anglicky, takže ja sa switchnem rovno. So welcome to this talk. It is about to be a talk of blend of architecture, DevOps and security. And let me introduce very shortly myself. So I'm Attila. I work as an architect at a Swiss company called Kistler. They are known for high precision sensors, and they are now providing full solutions from the sensors to the cloud so that customer data can get to the cloud for processing. I have some developer background. Let me just bring it back. Developer background and looking into DevOps topics, architecture topics. And yes, I also like animals and combine technology with some of the physical world. What is the talk is going to be about? First, we are going to have a reminder what is DDoS about. Then, through some 3 different stories, we are going to do some journey, learning about what happened to other people. And we are going to arrive at some cost comparison so that you can pick your own weapon when protecting yourself, and then finalize it with what to take away, what to watch out for in your own company, organization. But let me start with a quiz real quick. Before we explain what a distributed denial of service is, what would you think, just out of guess, what is the ratio between these 2 things? Like every euro an attacker spends on the attack, how much multiplication is there? How big of damage does it cause? So, okay, there are votes for 4 mostly, and you are very right. This is really the case, unfortunately. So if you have like $100, you can cause to a company which is unprepared, you can cause a damage of hundreds of thousands. So let's dive in. What is DDoS? And it's first of all, I would like to tell the difference between simple denial of service and distributed denial of service. Both of them are about intentionally causing harm to some target, to some company. But the first one is a single guy, single attacker, like no special infrastructure needed, but also his damage is limited. It's easy to block this single IP. It's not the case with the distributed denial of service, where you can have like an attack from hundreds, maybe thousands of different devices. So how does he pull it off? He actually uses some malware. He does infect some hundreds and thousands of devices, and these devices can be like routers, old PCs, even refrigerators. If you have like smart fridges, it can happen to them as well. So then he, as a single command, single guy in command, he can give instructions to this botnet and attack it, and it's very hard to block them. So it's a common cyber threat. It's not really going to go anyway. No signs of slowing down, and you can rent really a fleet of these bots for a couple of hundreds of bucks. Regarding impacts, there have been some explorations. How much does it cost? Like 10 years ago, it was, for a single attack, it was already possible to cause the damage of hundreds of thousands of dollars, but recently it's per hour more than $1 million. So it's getting bigger and bigger. And what is important to tell here also that not every breakdown of your system needs to be a DDoS attack. It's good to test it just for usual load as well, because it can happen that if the system is not scaling well, if it's not designed to scale well, it can go down under legitimate traffic as well, and that's really unfortunate. So let's test that if it's possible. Regarding the network, the attack types, we have a white or gray line and also a yellow one. The 2 types are, the white one is the network layer type, and the other one is the application layer type. They work in different means. but as you see the trend, it's not going anywhere. It's as if application layer attacks are going higher, but if we have a look at a more recent trend from Cloudflare, it shows a different picture. It's a most recent one, but it just tells us it's increasing and increasing. And what is the difference between these two, network layer and application layer attacks? They are about a different layer of the networking stack. So the SYN flood is it's a protocol-based attack where you abuse the TCP connection establishment process itself, and all the others are about amplification. Like very good example is the network time protocol, where usually when you are not an attacker, your computer goes out to the server, queries the time and gets back all the time details. But when you are an attacker, you can abuse this process in a way that you specially craft a request in a way that the server will not respond to you as normally would, but it will respond to your target, the victim. And the trick here is that you only use the few bytes to send this request to the server, but the response actually, with all the details of the time server and the time differences and the whole trend, it's like 50 times roughly the number of bytes you sent out. So it's like having a cheat code. You use your bandwidth to contact the NTP server instead of your target, but this bandwidth is multiplied by like 50 times, 50-fold. You achieve a much bigger load onto you put a much bigger load onto the target victim than you would be capable with just your infrastructure. So it's really the NTP servers don't even know they are being abused for this attack. So it's a very clever trick. The other type of attack is the higher level, application level, layer 6 and 7, using the TLS protocol or the flooding the server with HTTP requests, because in the end it's about exhausting the CPU resources, the memory resources, the bandwidth of the server, whatever it takes to bring it down. So, and ideally you would like to, during such an attack, you would like to block the malicious traffic, ideally like this. If the red is the malicious traffic, you would like to filter out all of that, and the green one, the legitimate traffic, your real users, those are the ones you would like to just pass through as if nothing would happen. That's the ideal case. In practice, unfortunately, the other case is more frequent. The most of the malicious traffic you can block out, but not all of them. And during the process, you inevitably sometimes also filter out some of the valid traffic, unfortunately. Let's have a look through some stories. The first guy is called John, and John is having a support shift. He's out of regular business hours, and now he gets notifications that the application is down, because that's when the attack is the biggest. And he's a clever guy, so the first thing he thinks about is, well, Occam's razor tells you maybe the simplest explanation is the best one. Did there happen any new deployment, any new bug fix? But none of that happened. So this would not explain why the application is down. So that's already a hint for him that maybe there is the rate limiting, which is in the application, is not effective, because then it was none of these two simple explanations. So it must be a DDoS attack. But the strange thing is that they relied on having this rate limiting to fend off this extra traffic, but they had it inside the application, which is quite late. It can collapse very easily under heavy load. So instead of this, a specialized network component or components are needed, which are really designed to fend off this huge malicious traffic. So what did he do? He knew about Cloudflare, solution provider which is providing you a content delivery network, also DDoS protection with TLS encryption. They even have a free plan. So the free plan is so easy to deploy for John that he was able to do this even under pressure of the attack. And what happened, what it looked like before and after. Before, his application was directly exposed to the internet. Like whenever the user asked for the domain name in the browser, yes, the DNS server returned this IP of the server, and the browser directly went to that server. When he did the migration, what changed is that their requests, the user's requests, are now redirected into this Cloudflare infrastructure, which is effectively doing something like this filtering, detecting what is wrong. And this way, the application is not anymore directly exposed to the internet. It's a reduced attack surface, basically. It also contains web application firewall, so it's possible to even do deep packet investigation, deep packet inspection to have a look at what the request looks like. So, and then it can fend off the attack better, much better. And what he gained is now also visibility. Where do these requests come from? And what he found is mostly from this single red country. But he was disappointed because it seemed like Cloudflare did nothing, because yes, it was visible, but the attack didn't stop. And that's the gotcha here, because yes, Cloudflare does give you the tools, but you are the one who needs to use the tools. And you need to configure, for example, the firewall rules. So yes, when he added a firewall rule, a very simple one, to block anything and everything from China as a whole country, that solved the majority of the malicious traffic. The rest was simply blocked by introducing a managed challenge. So all good for John. Looking back, historically what happened, he just had to, the spike here means like how he migrated into Cloudflare. So Cloudflare started to mitigate the attack, and it went down progressively to zero, effectively. So at the peak, it was almost 1 million requests per 5-minute interval. So it really shows you how serious it can be. And it ended here for John. But our second guy, Frank, he had some more trickiness in his story. And started similarly. Application was very slow for him. What was strange is that there was heavy traffic, like high usage of the application, but not high database traffic, which is unusual because more users should trigger more database traffic. Also, load balancers got triggered. So all in all, it smelled like a DDoS attack as well. So he had already web application firewall already in place, but again, it was turned off. So turned it on with the best hopes, but still huge traffic. So what's the issue here? He went to gain some more details from the logs from the web application firewall, and he found out most IPs originate from these 3 countries. Well, blocked them all, and it helped. Blocking those 3 countries. It was very good. So it seemed like a very good story again, until a second wave for him came. And now he already had, the next morning, he already had like 5 times the number of requests in the same amount of time. And he already was blocking some even additional countries. Still didn't help. So he was somehow clueless in the beginning. What he had to do is to block even all non-US traffic. He had a US company. Still not real good results. So he had to go out and find a pattern in the requests, like checking URLs, but nothing suspicious. He had to check authentication headers. Still nothing fishy. So he was really actively looking for what can be the one factor which distinguishes the malicious traffic from the legitimate traffic. Even user agent headers made really no difference. The only thing he noticed is as a header, usual header, connection header, which was set to keep alive, which was not typical for the application of the official application. And one of the possible attacks is exactly the slow loris attack, which overwhelms a server by simultaneously opening and keeping the alive connections. And this way, as soon as he blocked this header, he finally blocked the DDoS attack. Until a third wave came from him, because the next Monday, the DDoS was originating from the United States. There is no possibility to block the country. He even blocked all the bad reputation IPs, which are like dynamic rules, which the hypervisor itself manages for you. If some IP was taking part in some attack, then it's marked so that you can be protected. Still only 60–70% of malicious traffic filtered out, and the system was still down, the worst of it all. And what happened is that he had to look at the architecture of the application. Very, very much simplified. The API gateway cooperated with the web application firewall for protection, and after the load balancer got this traffic. But what he found out that there was a way, actually, a bug in the system, which allowed to bypass this API gateway, and with this also the web application firewall. So as soon as he fixed this extra path, which normally can be done with this origin cloaking, like reducing the attack surface, but by not allowing to bypass, or even introducing some security groups there so that load balancer only takes traffic from the API gateway. This is what solved it for him. So, happy guy. Third story is about Tanya. And Tanya has, again, nighttime alarms going off. And all the alerts really speak about, like, it seems to be a classic DDoS attack according to all the signs. And Tanya was prepared. He already had rate limiting based on source IP in the web application firewall. She had applied a known bad actors list. And still she had to look into the pattern of the attack. She blocked everything which could be done, but still new ways were hitting. And it really didn't look like just some script kiddie using some really small number of euros, to small amount of money to attack this, because it was constantly changing, rotating. It's really as if a real elaborated botnet was being used. Until Tanya noticed something special in the traffic, in some internal traffic, actually, because they had in the system a user profile, so-called user profile service, which was storing the user data, and an internal service, an internal API, which was really not meant to generate a traffic of successful API calls, and especially not in this high amount, of course, and especially not under such a load and such an incident. This was happening. So what she found out is that the S3 logs, which actually did store the user data, these logs also confirm this, that series of GET requests was as if sucking out the data from the storage. And there is a new concept which I would like to show you. This is the smoke screen. Usually this is used in military terms, like soldiers use this smoke screen technique, generating smoke just to hide their operations activity behind the eyes of from the eyes of the enemy. And this can be this can be used also for breaching, so security breaches. As soon as you have some of the internal build servers, for example, some internal server which has some slight vulnerability, an attacker can decide to take this route, like, let's say 5 steps. At first, the attacker just gains some foothold on that server, but just access. Nothing suspicious is going to be executed by him, because now, once he's inside, he starts executing a DDoS attack. Of course, it's generating a huge load of logs, and it's diverting the attention of the IT staff. Everyone is running around, and actually, that's a very good time for him to start sucking out some commercial data, some user data, something confidential, because that activity will be hidden and lost within the tons of and the sea of other logs. So the real damage is not, in this case, is not the downtime cost to the company, but really the exfiltration of the user data. And once this is done, he can stop the DDoS attack and, like, as a final step, just get lost. And this is not just a virtual scenario. This really did happen, like many times in history, to companies like Sony or Bank of West in San Francisco, or even Carphone Warehouse, which was like selling some cell phones. So this is really tricky. Now let's go to the comparison of what you can do to protect against. And protection against DDoS attacks is not the usual vulnerability protection, so that you just patch something and sit back and have it all sorted out. You actively need to have you need to have the tooling, but you also need to actively do some things to act. And what is needed is foremost the network architecture and its components, but this is mostly about mitigation techniques. You also need to have operational techniques like also auto-scalable services, of course, to tolerate this excessive load. But you need to have observability. You really need to be able to look into the logs to see how where is the most traffic coming from, what's the shape of the traffic, as you have seen in the stories. Without identifying some patterns in the data, you are really clueless what to do sometimes. Also, the last thing is having an incident response plan. Think about it upfront. When the attack is happening and it's already proceeding, it's too late for you to think about where do I look first, who do I notify, what management decisions need to be done to minimize the attack, how the company could deal it with the best way. So best is to have your own response playbook and then mitigate and recover based on that. We will have a look at it later on. To the cost comparison, I'm going to show you a graph which is 2D, but actually 3D. The third direction is the size of the shield I'm going to show. And starting from, and the two axes are costs. Actually, the initial effort, the horizontal axis is about like to change based on your company, because based on what you have established differs, and that's the initial effort about. But the most native approach is the same for everyone probably. You can have your reverse proxy, you can have some protection, rate limiting turned on here, which is better than writing the application, but still not good enough, because this reverse proxy still can break very easily. It's small protection only. It was not built for really fending off DDoS attacks. The next one is Cloudflare's free plan, which is free, gives you limited tooling, but gives you good enough tooling. If you have a very simple application, your own personal web page, this is really the way to go for you, because it also includes web application firewall, not only content delivery network, which is about mostly caching, like bringing the pages of yours closer to the users, offloading your real server, but also the cloud deliver, the CDN, the content delivery network. By doing this, it also fends off the network layer attacks. So you all need to take care about web application firewall rules on your own. Of course, it's limited, and much more flexible is what, for example, Amazon offers you in the form of CloudFront and combination with web application firewall. It is really can be fine-tuned dynamically based on your load. The holy grail of DDoS protection is something much costlier. Azure calls it DDoS network protection. AWS calls it Shield Advanced. And they are more expensive, much more expensive, but they are very good in one thing. They also protect you from denial of wallet. And denial of wallet is a new term. I should explain it. It's when your application gets a high traffic, and this high traffic is not taking your application down, but instead it's generating you a higher bill, a much higher bill you pay to your hyperscaler. So what it says that if AWS is protecting you with the Shield Advanced, which you pay for every month, and they are not able to filter out all of the DDoS traffic for you, and the attacker generates S3 traffic for you, the S3 service itself won't go down. It has huge scalability. It's provided by AWS, not yourself. So it won't go down, but it will bill you a huge, it will send you a huge invoice. Also, if the attacker triggers the Lambda functions a million times in a very short time, Lambda, again, it's an AWS-backed service. It's serverless. It won't go down. The damage for you will be a high bill. But these two services will reimburse you these costs. So if you can afford it, really go for this one. Now, attack mitigation, there are different sets of rules, like static rules, dynamic rules. Really depends on your use case, which one is best fitting you. Even some custom rules which are giving you even more flexibility. And I mentioned before this incident response strategy. And what I could recommend is to base it on these two templates. So the National Institute for Standards and Technology created a template for it. AWS based their template on this one, and you can base your template exactly based on this AWS template. And if you divide it into 5 parts, when a DDoS happens and it starts, the most immediate step for you is to start collecting and analyzing all the data, collect all the data. This is crucially important because later on, these collected data will help you prevent the next attacks, and that's what you want to ensure. Once you started collecting, the second step is the contain the incident. So do any immediate action you need to do, like any ClickOps is okay here. The goal is to limit the spread of the attack so that it doesn't escalate any further. When it is done, when you stop it, the immediate effect, then you can go from ClickOps into real infrastructure as code so that you can prevent the recurrence of this. You have now some small time to do this, and you need to ensure that it's really stopped and this same attack won't happen again in the future. The fourth part is recovering from the incident. So whatever you had to scale up in order to defend this attack, whatever scaled out, you can scale it down now, because now you are in the position that you are protected against it. You installed everything which is needed. And the last part is the post-incident activity. And this is the learning. This can take days or weeks. This is something to invest. It can seem to you that, yes, we are out of the deep water. It's everything fine. Everything works as it worked before. But if you skip this step, then you won't be really prepared for the next attack happening. And it can be really just a matter of time. So all in all, lessons learned, what to do and what not to do. So please don't rely on any in-application rate limiting. It's not meant to fend off any DDoS attacks. It's just too late in the infrastructure chain. Migrate your application, your DNS to content delivery as soon as possible, even if you don't need caching. Even if you configure that CDN to just forward to your servers everything all the time, even then it's fending off the network layer attacks. And be aware that you can't prevent a DDoS. You can just defend yourself from this, from the negative effects of it, from the worst impact of the DDoS. So have the tooling and have the understanding for it. How to prepare for this? CDN is not just for caching. Using web application firewall is of your cloud provider is really providing you many rules to choose from. Pick what fits you the best. Learn upfront to use this web application firewall. These can be complex components, but by being complex, they offer you flexibility. Really, really good way of. Once you know them, the possibilities, you are very good to in a very good position to fend off these attacks. Invest into observability. It's absolute minimum to see where the traffic is coming from, what the shape of the traffic is looking. If you have from the first one, from the previous one, if you have muscle memory on how to use these rules, and suddenly you see the shape of the traffic, you are really prepared. And then, if you can afford, go for some of these really advanced techniques, advanced services. Denial of work protection is really a must for you if you have a huge organization, and dedicated response team is something which is offered by these services as well. So you have professionals who deal with DDoS attacks almost day to day. You have these professionals at your fingertips, of course, for some cost, but these DDoS experts are then serving you. And the reimbursement of costs is only happening because, yes, if they were if they were not able to filter out something for you, then they will just return the cost for you. So thanks a lot. This was all I wanted to tell you. And if there are any questions, you can have a look.